I'm here to talk about a utility that I created called Crassus. And it's basically something that finds privilege escalation vulnerabilities in Windows products. Technically, it could do Windows itself, but the idea is like basically apps that run on Windows. And like one of the things around when I came up with the original idea for this is I'm sure people are familiar with the concept of imposter syndrome. And I'll say that like I'll get that if I ever look at like a Google Project Zero write-up or even at a security conference. And like it's very easy to become overwhelmed with like, oh, finding vulnerabilities is very, very difficult. Well, I'd like to say that I'm here to save the day for folks that might be falling into that particular category. So the type of vulnerability that this discovers, or that I can categorize as this, we've kind of labeled it as path escalator. So it's basically a privilege escalation issue related to paths on Windows. So a little bit of a background here. I'll go back to a former life of mine just a couple years ago, I'll say. And the goal was kind of given to me where I needed to be able to find privilege escalation vulnerabilities on Windows. And the technique that I kind of landed on was using sysinternal's process monitor. And it's actually pretty straightforward. The general idea is you, with process monitor, you can check this little option here that says enable boot logging. And when you reboot the system, it will save a log file. And then what I really ended up creating was a process monitor filter. The general idea here is that you are trying to look for missing files. The part that's kind of hidden across the bottom of the screen is there's a lot of things to exclude to try to like get the signal to noise ratio a little bit better. But this is the general idea: is you boot your Windows system with process monitor using this boot logging feature, and then you apply this filter. So this is an example. This is kind of like a stock Windows VM, Windows 10, I guess, with VMware tools installed, and it's a little bit much to look at, but and I apologize if this is a bit of an eye test, but because we're all in front of monitors, we might be able to see it. There is a vulnerability on the screen here. If anybody squints their eyes close enough, you can see something's not quite expected here. And this particular software, which is part of VMware tools, it's looking for program /program %20 files. Well, anybody who lives in the web world for like looking at like URL encoding, you'll recognize that, well, that's a space, but for some reason they URL encoded it. So like, let's fire up our non-admin command prompt here, and I can try to like write to Windows, and you can see access is denied. So like I'm not in an elevated prompt or anything. But what if I want to make that directory that the software is looking for, program %20 files? It just works fine. Windows, for some odd reason, allows non-admin users unelevated prompts to create directories right off of the system root. Now, in this particular case, it's ended up being just like an XXE vulnerability. So really, I couldn't really accomplish anything that useful. But here is an example of an actual real-world vulnerability that I found using this filter. And again, it's a little bit of an overwhelming sort of like wall of text here. The scary thing is once you become more familiar with it, you kind of learn to like read it, and you know, it's kind of like the Matrix where it's scrolling past you, and it's like, well, eventually you learn to see what's going on here. But if we look kind of closely here, we can see, and this is like some McAfee antivirus software. We all know that antivirus software keeps you safer and it makes you more secure, right? Wink, wink. Here we can see it's trying to open an openssl.cnf file off of a D drive. And if we look a little bit lower here, we can see it's actually trying to load it off of C:/user local SSL. In the POSIX world, where that's like front/ user local SSL, like no normal user could ever create that. But in Windows, that's a very different sort of thing. If you ever have a POSIX style path that's attempted to be opened by Windows, like you can just make that path. So what is it about OpenSSL.cnf? As I look, like, why would that particular file matter? Well, here's an example OpenSSL.cnf file. The whole top part of it, all the comments there, it's basically you have an OpenSSL init section, and then there's a thing saying /temp/calc equals whatever the heck you want it to be. On the Windows platform, it'll interpret that as C:/temp/calc.dll, and it will load that library. So we can actually see this in action with our VM with McAfee installed on it. It's trying to open C:/user local SSL. It's running with system privileges as the local system user. So that's kind of nice. We can see that it's loading the DLL that we placed there. That's kind of hidden behind my automatic annotation here, but if you look through, you can see that calc.exe is actually running. And we can see that calc.exe is running with system privileges. So like that's the privilege escalation. As a non-admin user that happens to have this vulnerable software on it, I can just run whatever the heck I want as system. So one of these things that I noticed is as you are looking at process monitor logs, you start to see things that are like, I don't know if I want to say if it's disappointing. Took a little bit of my heart and just kind of twisted it around. But some programmer somewhere, and this was some Dell software, how does it know if a path exists? Well, they decided, like, I'm going to increment it one character at a time and look for every single option along the way. Yeah, this is one of these things where it's like in the infosec world, once you start looking at things, yeah, you're either going to get a good chuckle or you'll be like kind of horrified by what you see. So let's move on to, at some point, I think it was just this past fall, Accenture released a tool called Spartacus, and it's a really cool tool. It's written in C#, and you can basically run it with Process Monitor. It will actually look at libraries that are loaded, and it will analyze those, and it'll see what sort of function, what sort of exports I need to have. It'll check to see what ordinal numbers I need. It does all of that stuff automatically, which is really cool. The part I didn't love was that command line. Oh, people don't like typing a lot of things. This is the command line that you would need to type in, fingers on keyboard, to be able to use Spartacus. So anyway, here's the actual list from the website. There's a lot of options there. And don't get me wrong, I think that the Spartacus tool is excellent. It's an excellent tool, but sometimes in the infosec world, simplicity can kind of trump your other options. Given two choices, people like the simpler option. So enter Crassus. And at some point, I started tweaking the Spartacus code, and I'm very clear about I am not a programmer. Any code that I write starts out with me Googling how to hello world, and then you go from there and you copy and paste stuff. However, because of the folks at Accenture, I was able to take pieces of existing code and kind of mix it around and add some features and do some things. And at some point, I got to the point where my tool was different enough than Spartacus, so I couldn't really call it Spartacus. So you use your favorite search engine. And who defeated Spartacus? Well, Crassus. This part I'm just going to put up on the screen for time reasons. Like, I'm not going to go through it, but this is the flow chart that Crassus goes through to find privilege escalation vulnerabilities. It is on the GitHub page. If you wanted to look through it and get an idea of what it's doing, that's fine. You can look at it. But honestly, you don't need to know this. You just run it, basically. So my first goal with the Crassus tool was like, let's make it simple. So here's an example command line invocation of Crassus. Crassus, you can even tab complete that. Logfile.pml. Logfile is the log that Process Monitor created when you booted the system, or it could be a thing that you recorded while you did a certain activity under Windows. But you basically just give it that log file. And here's an example of that very same virtual machine that had the vulnerable McAfee software on it. And I can see that there's two lines of interest here, the ones that are colored. The green one, that's like this is great. You found a vulnerability. I can write to c:/user local SSL. The reason that the other one is in yellow and it says that you should investigate it is because at this point, the D drive, that's usually like an optical drive. So whether or not you have control over an optical drive, you should look into it. In the case of the McAfee software, yes, it was as simple as if I had a system with the vulnerable McAfee software on it, I could insert a CD, reboot the computer, and now I own that device. Now, let's compare this to the process monitor log. This is the exact same system and the same vulnerability. You can either stare at this until like it just comes to you, or you've got the option here of look to see if there's any lines that are colored. So I consider that like kind of a nice win. One of the other things that Crassus does is not only does it look for missing paths, it will actually investigate paths of loaded libraries or spawned executables to see, can I actually write to that file? So just by looking at missing files, you're not seeing the whole picture, because I might have software that reads a library from an unsecured directory. So it could be that in the process monitor log, it actually successfully loads the file. But in this particular case, here we can see we've got a library that's loaded with system integrity. But it happens to be that I can write to that file. So it's a new vulnerability. It's not a missing file in any way. This happened to be from an Adobe product. I think it's in one of my upcoming slides, but it's just like real world vulnerabilities. Another thing that I thought was kind of novel in Windows, and I always thought if you have a process running from a certain directory, you shouldn't be able to like rename that directory out from underneath it. And it turns out that's not always true. It really depends on how Windows has the contents locked, whether it's a process that's being spawned or there are other resources that are being loaded. But it turns out that sometimes you can just rename a directory, and even if the process is running, you can rename the directory that it's running from, and it'll keep running under a renamed directory, which to me, I've always thought that Windows locking was a little bit more severe than that. This is in a real world application that I'm going to touch in an upcoming slide, but I can see right here, Crassus, the tool is doing this for me. These are all steps. If you're just using the process monitor filter, these are all steps that you as an analyst would need to manually do. I would need to fire up a command prompt. I've got to try to rename this. I'm going to try to place a file in a directory. All of this stuff is done for you. And that was like the recurring theme of why did I make Crassus? The general theme was automate the things that are like tedious and repetitive, which is kind of like, I don't know, that's kind of how computers should work in the first place. One of the things that it borrows from Spartacus is building DLLs, but the problem with Spartacus is it gives you a .def file and a .c++ file, and it says, well, have at it. You've got everything you need. But if I'm not, like I said, I'm not a developer. How do you go from a C++ file to like a DLL I can load? The idea here is, well, Crassus gives you batch files for building the library. So all I have to do is type build.bat and hit enter, and like I have my DLLs. Not now, yeah. When I started creating this batch script, again, not a programmer, but like when I look at the batch programming language, this is the Windows batch script language, like I have wonders. One of the arguments here is slash capital F lowercase e percent tilde nf dot dll, and like, so anyway, if I didn't provide this build script, you would have to kind of figure out that you have to do all this stuff to build a library. So if you have Visual Studio, that's great. Not everybody lives in the Visual Studio world. So like if you're one of these min-GW people, PowerPoint's a little bit weird with where it starts animations, but you can run build.sh. And as the result of that, I can see, all right, I've got one 64-bit DLL and I've got a 32-bit DLL. It doesn't even, you don't, as the end user, in the past, in the process monitor log file world, I would have to look, is this a 64-bit library? Okay, now I'm going to build it as 64 bits. Does it load into the process? Does it, if it doesn't load, then maybe I need to give it exports. It basically is, I just need to run the build script, and it basically does everything for you. So here's a real world vulnerability. This is going to be, how long does it take to find a vulnerability, right? 90 seconds if you read the title at the top. This is a real world application. If you have a UPS, there's a program on Windows, I think like APC UPSs, it comes with a thing called PowerShoot, and it does virtually nothing other than give you a new thing in your blank bottom of your screen. This is a utility that can allow you to run scripts or do other things or control how your system works. So all I've done is I've installed the software, right? Now, this is in a virtual machine. This is a virtual machine where I've got a snapshot for it where it's already configured to have process monitor create a boot log file. So all I have to do is when I'm testing various applications, you install the application and then you reboot the virtual machine. Most of the time is really just waiting for Windows to come back up. If you've got a really fast computer, you don't have to wait a lot of time. One of the tweaks that I made to the virtual machine is I configured it to automatically log in. Normally I type in my really secure 4-character passphrase to log in, and I do some things, and I do it. But basically this automates it for you. So when I boot it up, I also set up a batch script to start up and just run process monitor for me. And it'll say, hey, there's a boot log. It'll save that to a log file. And then you just save it again, just especially if it's an older version of process monitor. This ensures that it saves it as a single file. And when I close it, the batch script just runs Crassus on the log file again. So at this point, all I've been doing is talking. The only effort it took was I installed an application in my virtual machine, and then I waited, and then I clicked a couple things. There might be ways that you can automate that part, but honestly, when it gets to the point of just doing a click or two, I don't really care that much. So here we've got multiple things that I can exploit in order to go from a non-admin user to system privileges. And it tells me, I can see on the screen here, it's 32-bit. I could either rename the bin directory, or I could place these missing DLLs there. So that was like 90 seconds from start to finish. So just to go to this last step, this is on a machine that has the APC UPSD software service running. Now this service runs from the bin directory. I can actually successfully rename that directory to whatever I want. I make a new directory of the same name, and now I copy, as vulnerability researchers, we always pop calc So we're just going to copy calc.exe, and I'll give it the same file name. Now, when I reboot the system, I can see we've got services is creating a process. I can see it's called APC UPSD, but I can tell very clearly from the icon there that that's really my calc.exe. And it's running with system privileges. So it's like pretty straightforward. So one of the other things I wanted to touch on is about like one of the things that can affect whether or not applications are vulnerable or not. There's a lot of applications out there where you just install the app and you're vulnerable. Some applications have like insecure default directories. So most software will by default install itself to C:/program files or the x86 version of it. The reason those directories are secure, or the subdirectories in there are secure, is they are secure by default through inheritance. Meaning if I create a subdirectory under there, I need to do nothing else, and I will have a subdirectory that only admins can write to. But not everybody follows this guidance. So the APC UPSD app by default will install to write off of the root directory. As we saw from the video before, that gives us a straightforward privilege escalation opportunity. It turns out if I click that browse button and I browse into program files and put it into a subdirectory there, everything's fine. So despite the fact that it has an insecure default, I can choose to put it in a more secure directory. And as we saw at the end of the video, I don't need to go through this again, but this is just the result of installing into this directory. Microsoft doesn't recommend installing outside of program files, and this is the reason. If you have something that runs with privileges, which is either a service that's configured to run with privileges or a scheduled task that is configured to run with privileges, if it's running outside of program files, you've probably got trouble. Now, that's applications that default to installing off of the root directory. I'm sure folks here have encountered applications that when you install it, it asks you, where would you like to install this software? This is not the default install screen. So just be clear, this part that's highlighted that says, do not do this. I chose that. I just wanted to see, so third-party installers for Windows, I could assume that they're going to do the wrong thing just because it's not easy to write secure software. But what about Microsoft? What about a recent application from Microsoft? So this is SQL Server 2022. They give me the choice of where would I like to install that software. So if they're asking me, I feel like I should be able to answer in a way that does not affect the security of the system. Well, what are the consequences? If I run Crassus on my installation of SQL Server 2022, where I chose to install it off of the root directory as opposed to program files, I've got plenty of privilege escalation options here. So I can go directly from non-admin to system. One of the things that I ran into recently is you would assume, well, so if program files makes its subdirectories by default secure, then you could probably assume that everything that installs there is going to be right? Well, don't count on it. This is actually only from like a week or so ago. I found an app called Emia, which I think is for emulating Android platforms on Windows. This is currently a supported application. So they're currently developing it and they're making changes, but it turns out it installs to a subdirectory of program files, but they explicitly set the ACLs on their installation directory to make it insecure. according to Crassus, at least, right? Like it's showing me here that I can do a lot of things. Well, how, if you look at what they're actually doing, if I hit the property in Windows Explorer for this MU, it's a mouthful. I can see that the everyone group has full control, and it includes a privileged service. Only after this, I realized this is actually a known vulnerability. It's been known for like 3 years. Again, I apologize for the captions overwriting it, but use your favorite search engine and you will find it. So it's been known for a while. The developers either don't know that it's been known publicly for years, or they're, not, can't be bothered to fix it, perhaps. So this is a tool that I developed shortly after Spartacus was released. I think I had a working thing around like January or something like that. So in the process of testing to make sure that my tool is working, I actually tested a lot of software. And I found a lot of vulnerabilities. I feel like I probably maybe like 30 or so since January. It's a lot. And like reporting vulnerabilities to vendors, I have a certain part in my heart that goes out to you with the diligence that you may have when trying to report vulnerabilities, because my experience was not great. First up, we got Python. Now, to be clear, this is only if the user chooses where to install Python to. They're given the choice. So what if they take advantage of it? So I send them a thing saying, hey, you should maybe fix this. Thanks for the report. They say this customization is outside of our ability to protect. Kind of a dusting your hands off, not our problem. If a user deliberately chooses where to install the software, they are choosing to have a privilege escalation vulnerability. So that's a certain amount of faith in the people installing software to understand that, like, if you take advantage of an option that's given to you, you might completely compromise the security of the platform that you install the software onto. So I did another one through HackerOne. If anybody's ever had to deal through HackerOne or Bugcrowd or whatever, your first level is generally triage, right? Thanks for your report. The attack you described requires that a folder is added to the system path be writable by any user. Therefore, this is misconfigured in the first place. As a result, we'll be closing this report as informative. And it's like, this is for an application that I clicked through the installer. I didn't choose anything. Eventually, Adobe fixed their software because it was a legitimate vulnerability, but it took a lot of effort to get through that first round of triage. Like, it was painful. And it makes me wonder about the skill level of the folks doing this triage. And if the people doing triage, and I'm assuming that Adobe or whoever's using these platforms is paying money for this triage, I kind of wondered at some point, are they getting the value that they're paying for? Well, let's not just pick on HackerOne. Let's go to Bugcrowd. We had another one, it's basically use your search engine to find out how to report a vulnerability, and you'll probably find Bugcrowd or HackerOne. Hi, W. Dormann. Commercial vulnerability scanners often produce false positive report results, and their output must be validated manually by the researcher before submission to Bugcrowd. Can you please demonstrate how this could actively be exploited? Please do not link to CVE issues. You must show definitively that the issue is present. And I'm just like, the tool that I wrote to find the vulnerability that I confirmed looked like a commercial vulnerability scanner. So therefore, person following their flowchart for the flood of reports that's coming in. I feel bad for the folks having to do triage because they're getting reports from all across the world. So like at some point they put their shields up and they just don't want to have to deal with things. So I feel for them, but at the same time, if you're putting yourself in between the security researcher and the people who write the software, you're not doing them a service. It's kind of a disservice. This is CVE to be determined, because I eventually got through to the vendor and they're fixing it, but the fix hasn't been released yet. And I'd prefer not to drop an O-day just because I'm nice. There was another app that had a platform called Inspective, and I got a message from somebody called Inspective Bot. Hi, Will. Thank you very much for your time and patience. Please tell me the software versions that you're using, and please provide a video. And it's just like, I get it. You want the video because it makes your job easier. But when the result is so straightforward, like I really wish I didn't have to deal with that. That one, I believe, is also CVE is TBD, because I eventually, or no, sorry, that one is not CVE TBD. This one, I failed to get through to the vendor because they eventually closed the bug report. And like, I went probably like 8 or 10 rounds with them and I finally gave up. This was from a product from a vendor called Razer, which they do like gaming mice and stuff like that. And like, there's a Razer component that you can install where it does something with the system-wide path that is very unsafe. But Inspective successfully prevented my report from going to the vendor. So it's all on you. So go ahead and do your Privesc on Razer installed systems. Here's one from a large vendor. This is one that gets me like starting to like feel good about humanity. W. Dormann, awesome finding it. We are triaging it now. I appreciate your patience. This one is CVE TBD. I'm not naming them. It's a very large vendor writing a very important product, and like, you know, they're fixing it. This was another one. My final result was from Spark Labs. Thanks to your patient, your report generated some internal discussion, and it's like, you know, this is another one where the user had to manually choose where to install the software. So like most people, this wouldn't affect most people, but it is perhaps an issue. And they said what we ended up doing is we ultimately decided that if the user chooses a directory, we're going to warn them that they might have a security impact. And I think that's great. It's not messing around with manually setting ACLs. It's not like your Python folks that just said, well, you know, screw it, we can't do anything about it. They're actually saying to the user installing the software that, hey, what you're about to do might have a security impact. There is a link here. I'm not sure if Grim is going to be sharing slides, although my slides have animations in them, so it's probably like 100 megs or so. But anyway, use your favorite search engine. You can probably find the report for that. Now, my request to you as the audience is go find your own vulnerabilities. In the process of developing Crassus, I tested a bunch of apps that had free versions available for download. So I can download a trial version, I sign up with my throwaway email account, and then I download the software and I can test it. What I have not tested is basically commercial software, software that costs money, software where the vendor doesn't like to give out trial versions. I noticed that with a lot of like EDR products, which definitely run with privileges. So anybody in the audience here, please go ahead and download the Crassus tool. It's a Visual Studio project, but there's also a precompiled executable. Just as a warning, the precompiled executable gets recognized as a virus by like 20 or 30 different things on Virus Total. Well, I don't know if they call it a virus, but it's a security tool. And we all know that security tools are evil. And like, you should never allow a security tool to hit the platters of your hard drive. So yeah, if you download the precompiled one, or if you even if you compile it yourself and you're running AV, it might delete the file out from under you. I'll leave it up to you to figure out a way around that. So yeah, that's our Crassus tool. I'm with an organization called Ball Labs, vu.ls. I think our website is actually quite new. But that's it, and I think I will open it up for Q&A. I think we're vaguely close to even being kind of on time.
Yeah, great time.
You were good on time. Oh, and my webcam has gone stupid again.
We see. Oh, there you go. Anyway.
Oh, cool. My question's first.
Yes, question.
Yep. All right. So, have you tried Crassus on Procmon for Linux yet? Did you see that they ported it to Linux?
I have not, and the reason I think I have used it in the past, and Procmon for Linux is a Procmon-like utility that runs on the Linux platform. The problem is under the hood, it's like got a lot of differences. I think one of the main differences is like one of the things that makes this thing like a usable tool is on the Windows platform, there's a little checkbox that says, hey, monitor my boot process, right? And when you check that, what it ends up doing is when you boot Windows, it early on in the boot process, it loads a process monitor driver. And then that driver starts writing log info to, I think, your Hibernate file or something like that, where upon Windows booting and you run Procmon, it'll say, oh, hey, I see that you've got a boot log. I don't think that on Linux you would even have the ability to get a boot log. However, just to be clear, Crassus does not require a boot log. You can actually like start logging with Process Monitor, do some things that are maybe privileged, and then save that file. So yeah, long story short, I have not tested it with Linux. I have some concerns. If it ends up producing a PML file of the same file format, then it's plausible that it could work. The thing about Crassus is there are some very specific Windows-specific attributes to it, where one being a C# program, but it's also looking for Windows API things like OpenFile and other things that just flat out do not exist under Linux. So we'll just say it does not work.
Fair. We got our next question.
A new tool for a cross-platform thing, if you haven't tested it, it's probably a safe bet. Let's see. Do we have any other questions yet?
So I see a couple I could read off the doc, but if you guys want to put it up, we can read it from there too. All right, I'll just go off the doc then. So is there a way to protect against the kind of vulnerabilities that Crassus can find?
That's a great question. I actually had answered that question when we did a blog post for it about the process monitor filter, and there is a way that you can protect, and I would recommend this for anybody that cares about protecting their system. And I think I even might have a slide for it. Let me look. Yes. So I think I verbally touched on this earlier, but by default, Windows allows non-admin users to create subdirectories off of the system root. For anybody who lives in like the POSIX-y world, like your Linux or whatever, like that is like a horrific, like mind-blowing sort of thing. Like, why would you possibly allow users to do that? I contacted Microsoft multiple times, gave them a long time to think about it, but like they refused to change this, presumably because they have some shitty old software from like the Windows 98 days that like is gonna break or something. I don't blame Microsoft for wanting to minimize the amount of support calls that they get, because every new support call they get costs them actual money. But when it comes to security features like this, I just wish that they would have like a little bit more of like, you know what, we're not going to allow this. And I might have some terribly written third-party software that like the vendor might come to me and say, hey, how dare you make this change? But honestly, this happens in the infosec world. Platforms get more restricted as time goes on, and like vendors deal with it, and we've all move on and make it better. So as an end user or as a sysadmin that manages Windows machines, you can go to the preferences and you can roll this out through group policy or whatever your mechanism is. You can remove the ability for authenticated users to create subdirectories off of the root. I can't imagine why somebody would need it other than just like really crappy old software just does that by default.
Well, thank you so much. Appreciate
Well,
your
there is
thoughtful
one
answers.
more sitting in the comments I saw.
One more.
Oh, is there?
Oh,
good.
there we go. So, which vendor is the easiest to work with that you've had experience with so far?
Easiest vendor. That sounds like a trick question because I think every single bounty platform I went through was like pulling teeth. I don't have a good answer for that. All I will say is if you are going through a bug bounty program, and honestly, I would recommend it. Like Crassus is freely downloadable. If you have access to software that's, like I in no way believe that I've tested a good swath of software that exists out there, but the percentage of apps that are vulnerable, it's pretty high. And especially, the ideal situation is you go and you click through the installer and you find a privilege escalation vulnerability. That's your lucky case. If you want to, I almost think it's kind of cheating, but if there is an application that allows you to choose where to install it to, install it right off the root and run the tool and collect your bug bounties. I think where I was going with that is I don't know if there's a really good vendor to deal with or a bug bounty platform to deal with, but I will say try to stick with it as best as you can in that, like, okay, I'll word it a slightly different way. Realize, I get it, you're a security researcher and you're submitting to a company that you expect to be highly skilled. When you're submitting something to a bug bounty program or even just a vulnerability program, no bounty required, you have to understand that the person that's doing your first level triage is likely unskilled. It's the same sort of thing that if you're calling up tech support, the first person answering the phone is probably paid less than like your really skilled employees. So you have to get past that first level. So you have to have a little amount of diligence and patience to get past that first level of like triage. And please just, try to, you will likely get frustrated. You'll have to take a deep breath. Please do not drop Ode, but honestly, do what your heart tells you. Yeah.
Words to live by.
Well, thank you so much, Will.
Okay,
I love
great.
the talk. I love the tool.
Excellent.